So, in the interest of starting on time, we have 1 hour, so want to have plenty of time for Q&A. And so, why don't we get just a quick sanity check? Can someone type in or indicate in the chat that they can hear me and that the sound is good? And then away we'll go. I got two people with raised hands, but just try and type something in to say the Q&A. All good from Toby. All right, great. Sounds good. Well, I wanted to teach a 1 hour webinar on retrofitting solar with batteries, mainly because I used to be a solar installer before working at Fortress. And, I've been in the industry like many of you for, a decade or so. And, man, there's a lot of solar out there already, and almost none of it has batteries. And so, what do we need to know when approaching these project sites in terms of design and development? Is there an easier way to retrofit systems? Is there a more difficult way? What we're trying to do today is discuss those issues specifically. Just real quick, Fortress Power, if you don't know by now, we make lithium batteries for residential and commercial applications. Our headquarters are just north of Philadelphia, and then we also have offices in China, California, and Puerto Rico. So we are fast becoming a global company with some private equity backing and a real market focus on North America and South America and Central America. We have primary distribution warehouses on both coasts. And so when you place orders from us, they ship to all of your mainstream solar distributors within a matter of days, no matter what part of the country you're in. Pretty much like everyone else in the industry, we are looking at that extra 10% from the IRA, saying, well, how can we bring manufacturing and assembling over to the United States to take advantage of that? It will probably start first in the commercial industrial side of the Fortress business line. But now let's get to the topic at hand. Why focus on retrofitting existing solar with batteries? And the simple answer is a solar array is incomplete without batteries. I mean, every customer for the last 15 years has said, oh, so this solar array will work when the power goes out. And solar installers have had to kind of sheepishly say, well, no, it really just lowers your electric bill and helps the environment. But, in terms of backup power, you need a battery for that. And batteries have traditionally been so expensive that most installers have opted not to install them. But what that means is that we have, thousands and thousands of job sites where the solar array is already installed. And, that could mean going back into, your past book of business and upselling those satisfied customers on new services such as retrofitting batteries. It could also mean going into your market and building up your brand name by targeting low-hanging fruit that your competition is sleeping on. I mean, and not in all areas, but say in Austin, Texas, it's really easy to just go onto their website, go into their permit search database and find, a list of, 1,000 solar owners. You don't get their names, but you get their addresses. And you can pretty much guarantee that every one of these solar customers that has pulled a solar permit in the last 10 years does not have a battery associated with their system. And The fact is batteries are adding value to project sites because it's what the customer wants. They want the backup power when the grid goes out. It doesn't make sense to them to own a solar array and not have backup power. But B, the rate structures are making selling back to the grid less economic and making daytime electricity less economic. And the combination of net metering rollbacks and increases in availability of time of use rate structures means that the battery adds as much value to the project, and in some cases more value to the project than the solar array. And in the case of prior customers, their solar arrays are already bought and paid for. And so when you think about it, in terms of going to a customer and having to sell them a solar array plus a battery versus just a battery, that battery is going to represent the most amount of value for the least amount of upfront cost. And so that's why developing a business model that targets battery retrofitting of existing solar is so great. The customers are, for the most part, already qualified. They definitely want the batteries. And, if they got in early on solar rebate programs in those regional markets, their solar array may already be bought and paid for, and that they just want some batteries to go with. Now, I tell solar installers, look, I know why you got into the business of installing solar, and you're installing solar instead of, other construction trades because solar is relatively expensive to install and installs in a very quick period of time. And so if you like that aspect of solar, that you can actually sell a project, make a good profit margin off of it, have good labor rates if you're on the labor side, have good sales commissions if you're on the sales side, if you're a business owner, you have better margins than in other construction trades. All of that is driven around the cost of solar and how quickly the projects can come out of the ground. And if that's what attracted you to the solar industry to begin with, you're going to love selling batteries because they're even more expensive than solar, at least per square foot, and they install even faster than solar if you know what you're doing. I mean, if we're talking specifically about battery retrofitting, you don't even have to get up on the roof to do a battery retrofit. So just the liability alone, most electricians would rather stay on the ground than get up on a rooftop. So just selling the battery component to an existing solar array owner represents the most cost-effective, valuable project that can be installed, sold, and developed in a short period of time, if you happen to be in those markets where the solar industry has been alive and well for at least the last decade. So hey, why retrofit? It's easy to identify who your customers are. Do they have a solar array on their house? Great. Though they're probably interested in adding a battery to their project. And all we need to know is how not to make a mistake going into the project. So to design it appropriately. And hopefully by the end of this class, you will be able to identify those things. Okay, so an age-old debate in solar battery design is, do I go with DC coupling or do I go with AC coupling? Let me see if I can get my controls out here. Not pointer options, pen. Yeah, so with DC coupling, the difference is, your solar modules are tied, at least in the battery terms, directly into the battery bank, and then the battery is tied into the inverter. And so we have, right here is where the DC side end and the AC side begins. And so DC coupling and AC coupling in battery terms is referred to, oh, do you tie the solar array directly into the battery bank on the DC side, or do you have a separate inverter for your solar array and a separate inverter for your battery bank? When we're talking about retrofitting, what we already have on site is the solar array with the inverter. And so often retrofitting, the easiest path forward is just adding a battery and a battery inverter. And we're going to get into those reasons why, but if you're looking for the project that is simple and fast and easy and not complicated, AC coupling is going to be the path you want to take for retrofitting in most cases. Now, we're going to talk about some DC coupling considerations as well. Simply put, there are a few different kinds of popular inverter architectures. In the United States, most solar arrays are either going to be DC optimizers, such as what you'd find with SolarEdge, or AC microinverters, which is what you would find with Enphase. And if you wanted to DC couple the system, basically, if you wanted to replace the existing inverter with a hybrid inverter like the Solarc, which is pretty popular, what you would have to do is get rid of all of this proprietary module level panel electronics, and you'd basically be throwing out the existing inverter system and replacing it with a brand new inverter system. And in the United States, at least, here in 2023, there are rapid shutdown considerations that say you actually do need these little boxes behind every solar panel. And we're going to talk about where that's going in the future, a few slides from now, because there is some relief coming on that issue, but the relief is still years away. Now, if you have a very old school customer who got into the market in 2009, maybe 2010, maybe all the way up to 2013, they may still have a string inverter, and they may not have been required to install these module level boxes. And so if they have a proper string inverter that's not a SolarEdge system or not an Enphase system, well, then replacing this string inverter with a hybrid inverter that does both solar string inversion and battery inversion would be a possibility. But more than likely, your inspector is going to come around and say, well, since you swapped out the inverter, we also want you to get up on the rooftop and put these module level shutdown devices underneath each system. And now there are devices that do not cost what a DC optimizer costs, or do not cost what a microinverter costs, that would meet these rapid shutdown options. They're called rapid shutdown only devices. They just act as a disconnect rather than providing more advanced features. But most installers aren't going to want to do that. They're not going to, if they want the easy project where they don't have to get up on the roof and take the modules up off the roof and mess with whatever's underneath it. So just by process of elimination, in terms of getting rid of all of the complicated project aspects, AC coupling is going to win for retrofitting because it's much easier. Now that could change in the future, and we'll talk about those considerations down the line. It would be a good time to announce that Fortress is now in the inverter game. So we no longer are just a battery manufacturer. We are also selling a 12 kilowatt hybrid inverter. And while we're not going to go into all the technical details of this hybrid inverter in this webinar, what I want to point out is that Unlike some of the more popular hybrid inverters that are dominating the 48-volt hybrid inverter space on the market, our hybrid inverter does go up to a true 600 volts on the solar array side of the system, at least for your design voltage. And so what that means is that if you had a system where you were wanting to retrofit string inverters and you had designed those circuits to be 600 volts, as is typical of most string inverter systems, and for whatever reason you did not need rapid shutdown options, what's really nice about the Fortress NV hybrid inverters, you could just take the old SMA or Fronius off the wall and replace it with a Fortress NV inverter and not have to redo your solar circuit configurations up on the rooftop. And so in the specific case where you have a string inverter and you don't need rapid shutdown on your system, that would be a great reason to do a DC coupled inverter swap. But pretty much any other reason, and that's pretty much going to mean every grid-tied solar array in the United States, or even off-grid systems that are still subject to building inspections and permitting for the most up-to-date version of electric code, AC coupling is going to be the more simple path forward. So I'm sure you're going to hear lots and lots and lots about this hybrid inverter, but to stay on topic, we're trying to make our training classes to be about a 40-hour series, and some of our other content gets more into those technical details. We'll stick around for the Q&A. Let's get back on track and talk about what you need to know when selecting an inverter to add to an existing solar array. It's actually gotten a lot easier than it used to be. The old school way of AC coupling was you would follow this rule of thumb, and you'd say that the battery inverter must be larger than the existing solar inverter. And that's because if you have, say, a battery inverter that's only 8 kW in size, and you have a solar array that's 20 kW in size, and you try to force 20 kW of power through connections that are only sized for 8 kW, you'll burn up those connections. It's not sized appropriately. And so, if you had been doing solar design with batteries and retrofitting for the past 5 years or so, and we didn't have all these brand new, wonderful product features that we have today, you would just say, okay, well, if you have a 10 kilowatt solar array, on site with 10 kilowatts of inverter capacity, you would need, around a 12 kilowatt battery inverter to accommodate AC coupling. And that had its own problems. The main problem being that battery inverters were very expensive and they were not sized for 12 kW. They were more likely to be 8 kW or 6 kW. And as batteryless solar marched along, I'm thinking about SolarEdge here in particular, the systems on your roof would get larger and larger. So it's very common to find SolarEdge systems that are 10 kilowatts or 12 kilowatts. And that would mean you would have to be getting into 16 kilowatt, 30 plus kilowatt hour installations on the battery size that were frankly too large for the customers to afford, especially at the price point of lithium batteries, 3 years ago, 2 years ago. And so for these reasons, AC coupling in years past, installers would get to the point where they wanted to add batteries to a solar array and then just say, well, the solar array is so large that to do AC coupling, we would have to have a much larger system. Why don't we just go ahead and swap out the inverters and redo the MLPE on the roof and do DC coupling, or otherwise the systems, they would only sell to very large systems, or they wouldn't be whole home backup systems, or the solar array wouldn't be connected to the backup side of the system. It's like, oh yeah, we can put the battery on your house, but the solar array is too large, so it'll just remain grid tied. These are dissatisfactory answers to the problem. So we're going to get to the kind of the new way of doing it in a minute. Just keep in this in mind. The old school way of adding batteries to solar was to make sure that the battery inverter was larger than the solar inverter. Just a way of proper energy flow. You wouldn't want more energy than what the equipment is rated for to flow into that piece of equipment. Now, one advancement in battery inverters that has been made in the past year is that now these 12 kilowatt battery inverters have what's called a 200 amp pass through. And at the tail end of this presentation, we'll talk about what I call Tesla style, where you don't have one big inverter governing everything, but you have an external transfer switch over there and a hybrid inverter over here at different parts of your array. And that's a valid design. We'll get into the reasons why to use that kind of design format or when to use that design format. But what's nice about hybrid battery inverters today, I'm thinking about the Solarc 15K in addition to the NV12K, is that they have the 200 amp pass-through feature where you have the grid side of the inverter and the grid comes into the inverter. And even though the inverter can only provide 12 kW of power, and that's true for the Solarc 15K, even though it's called 15K, as well as the NV12K, which we chose to call 12K. But if your home is drawing 20K or 30K of power, what it does is it uses the grid side pass-through current. The grid can provide 200 amps of power, and that's at 240 volts. So a volt times an amp is a watt. That's 48 kW of power. So even though you can only get 12 kW of power out of the inverter itself, because of this kind of 200 amp pass-through feature, you can connect it to a 200 amp service panel. And when the grid's online, you have access to 48 kW of power. When the grid's offline, you only have access to 12 kW of power. That in many jurisdictions, they'll say, well, you have to prove to me that the home doesn't go above 12 kW of power. Otherwise, you have to implement some kind of monitored load control to supply that power. In other instances, it may be a little bit more simple. It may just mean that when the customer goes into a blackout mode and then they use too much power, the inverter will turn off, and then the customer will have to realize that they can't run their air conditioning at the same time that they're doing their laundry and dishwashing, that they have to manage their energy through automatic means or manual means, one way or the other. And of course, later on in the program, we're going to talk about how to get even more power out of these systems. But to come back to the topic of the program, the old school way of AC coupling was to take that solar array that's already on its existing inverter and connect it to the load side of the inverter. And so if this load side of the inverter is only rated for 12 kW, that means that the solar array that can go into the load or also feed back into the inverter has to be rated for less than 12 kW in order not to burn up the terminal block that the wires are in or attached to. what that means is as solar arrays got larger and larger, 15 kW, 20 kW, one solution was, well, just tie the solar array over to the grid side. But that meant when the power goes out, you don't have access to your solar power. So, that's dissatisfactory as well. So there was a real problem with AC coupling design formats, in that just one inverter really didn't suffice for AC coupling. You'd have to do two battery inverters and really big battery banks, and that got into a question of affordability for most customers. There's a new way of AC coupling, and Solarc has been a big pioneer on this, and we work closely with Solarc, and our inverter's new. And so if you want to stay completely within the Fortress inverter platform, then that's a great reason to go with the Envy. If you're already familiar with doing Fortress Solarc combinations and you like both companies, by all means, keep doing that. Solarc works with multiple battery options, and we work with multiple inverter options to fit customer preferences. But the new way to do AC coupling is not to tie it in to the load side of the inverter, but instead to cannibalize the generator port on these hybrid inverters and say, you know what, instead of tying the solar array downstream of the load, I'm just not going to have a generator, and I'm going to tie my solar array into the generator port. And why would you do that? Well, often on at least the Solarc 15K and the NV12K, the generator port is rated for about 20 kW worth of power. If you have a 22 kilowatt generator, a 24 kilowatt generator, you can connect it to that port. You might get a little bit of clipping off the top end of the generator power supply. But if you're not using a generator, and most grid tied customers with solar on their roof do not have generators, and so we're not telling them that they have to go out and buy a generator. What we're saying is, well, we'll just use the generator port for AC coupling, because it's a larger port than what the load side of the system is rated for. So you can put a larger solar array into that generator port and sell some of that power to the load, but also sell some of that power back out to the grid in your net metered billing structure, your grid buyback billing structure. And so you could put a 20 kilowatt solar array onto the AC coupled generator port and still have that system work efficiently without clipping, by a combination of selling to the load and selling to the grid, and also selling from the solar array to the battery, charging the battery up at the same time that you're powering the load or doing some grid sellback. I think I've explored this a little bit further here. So compared to tying in AC coupled solar to the load side of the battery inverter, if you tie it into the generator port, you can accommodate much larger inverter capacities and remain within compliance of the inverter warranty. The other reason is not just that you get that larger port to land on in terms of capacity, but you also get monitored output. If you tie in your AC coupled solar array into the load, well, then all of that power gets mixed together with your existing electrical use. And so by the time you're like backfeeding into the inverter and backfeeding into the grid, or backfeeding into the inverter and then charging up the battery, the electricity from the solar array has already been spent powering any existing load. And so you don't really know how much power is coming out of your solar array. So you don't know what your true load information is, and you don't know what your true solar array output is. And so when you go and tie in your AC coupled solar into that generator port, that is a monitored generator port. And the load is a monitored port as well. And so by separating out the AC coupled solar from your load and putting them on separate monitored ports, you know exactly what your load information is, and you know exactly what your AC coupled solar production is. So it's not really a generator port. It's a port for a generator. It's also a port for AC coupling. It's also a port for load control if you aren't using a generator or AC coupling. So really calling this a auxiliary port rather than a generator port would be a more accurate term. And then last but not least, we kind of touched on this briefly, but the Solarc 15K is a 12 kilowatt battery inverter, but they call it the 15K because it has a 3 kilowatt, what I call bonus. And what that means is if your solar array is producing 15 kW of power, you can put 12 kilowatts into the loader battery and sell an additional 3 kW out to the grid. Or you could put 15K total out to the grid with nothing going into the battery or nothing going into the load, should that circumstance arise. And without fully understanding that concept, what it means is, even though it's a 12 kilowatt backup inverter, there is a means by which you can get 15 kilowatts of power out of it. The NV in comparison is a 12 kilowatt battery inverter like the Solarc. It cannot do 15 kW of grid sellback. It can only do 12 kW of grid sellback, but it has a 6 kilowatt bonus in the sense that it can charge the battery and the load to a total of 18 kW at one time. So watt per watt, or really more specifically watt hour per watt hour, you can get as much, if not more, throughput out of a NV inverter versus a Solarc. You can put 18 to 20 kW of solar power onto the NV inverter without any clipping. And what that means is with the NV inverter, with just a single NV12K, you can efficiently AC couple, a 15 kilowatt solar array, a 20 kilowatt solar array, or just about that onto the generator port. Long story short, the generator port of these large format hybrid inverters can accommodate 90 amp to 100 amp AC coupled systems, and that has reduced the amount of inverters that you'd had to buy previously when tying in the system to the load side. So AC coupling seems like a very straightforward and simple way to do an installation, and it is. If I were selling a solar retrofit, I would be doing an AC coupled system. But there are purists out there who will say, no, DC coupling is the best way to go, so only do DC coupling. You will find that, out there on the internet, in your discussion boards, and also at your NABCEP conferences in discussion. And there are some downsides to AC coupling that should be known and that are a little bit confusing. The first is, well, what if I want to use a generator? So I want to have AC coupling and a generator. What do I do? A pragmatic solution, and keep in mind, we're not talking about 200 amps at this point. We're talking about 100 amps, so the costs go down on this component. But a pragmatic solution would be to put a three-way transfer switch and to tie in a generator and tie in your AC coupling into that 100 amp manual transfer switch and then tie in the transfer switch to the generator port. And that way you can only have the solar array or the generator running, but not both at the same time. You say, now wait a minute, I know that SMA in the past has done simultaneous generator running and solar production. They do solar diesel hybrid camps to, your solar array reduces the amount of diesel that your generator is using. And the answer is that that works at scale when you have relatively known base loads and relatively known amounts of solar power, and you might just have a small solar array with a large base load, so you don't get into the issues of backfeeding. But by the time you shrink all of this down to a residential level, a residential home could have a 500 watt load for 5 minutes, and then it jumps up to a 20 kilowatt load, the next 5 minutes. Or it could be the summertime, the air conditioner is always running and not turning off. Loads vary, home loads vary quite a bit. And with AC coupling specifically, there isn't an intelligent communication going on between the inverter and the solar array. It's almost like you're two separate teammates, but you have to communicate in an analog manner. Now, the way inverters communicate to other AC coupled inverters is through frequency shifting. They're mainly concerned about turning the inverters off. And inverters, in order to be grid listed, they have to, without talking to the grid, they have to recognize when the grid is offline and turn themselves off. And they do this by regulating their frequency and only operating within a defined frequency range. And we use the same mechanism for your hybrid inverters to talk to your AC coupled solar arrays. When the batteries are full, a hybrid inverter will adjust its frequency to not turn off the electronics in your home, but to trick the solar inverter into thinking the grid is offline because you're now running at 62 hertz instead of 60 hertz. And so the solar array will turn off when the batteries are full. The problem is really that you can't implement frequency shifting very well when a generator is running. And so to maintain that, to be able to turn the solar array off to make sure that the batteries don't fill up and then the solar array begins to backfeed, what would normally be the grid. And when the grid's online, that's fine. You backfeed away. But in a backup mode of operation, if you have a generator there, or you don't have anything there, you just have the inverter with nowhere for the power to go, the batteries fill up, and then the inverter needs to turn the solar array off. It needs to be able to frequency shift, so it can't manage a generator and an AC coupled system at the same time very well. That's where, Enphase with their IQ8 system, it took them a very long time to get, solid communication, for all of their multiple AC coupled inverters on site. There's a little bit more to this. But the way that manufacturers ensure that you don't have AC coupled solar arrays overcharging the batteries is they will charge the batteries up to 100%, but when that AC coupled system turns off, the system will operate strictly off batteries for a period of time, typically draining the batteries down to 80%. Before charging the batteries back up again. And while that makes sense in the eyes of a manufacturer and certainly a battery that is used a battery that goes from 100% to 80% and back up to 100% and down to 80%, a battery that is used rather than kept at 100%, is a more reliable battery because you know that it's working. Um, so from a manufacturer perspective, we're happy to see batteries to go from 100 to 80, back up to 100, down to 80, back up to 100. That way we know the battery is working well, and that type of gentle use is not really impacting the battery life one way or another. Batteries don't have infinite life, and so if you don't use the battery, eventually you will lose the battery no matter what. But it's confusing to customers. That's the real drawback is the customer gets used to their system. They don't look at their monitoring until there is a power outage. And once there's a power outage, they're like, oh boy, the only thing I can do is look at my solar monitoring app, my battery monitoring app. And then they go, well, wait a minute, the sun's up and my batteries are at 85% and the power's out and my batteries aren't charging. There's something wrong with my system. I need to call my installer because I'm about to run out of power. And, they panic, as, maybe they should, because to them, the sun's up, the battery should be at 100%. So there is a little bit of confusion in this buffer zone that manufacturers need to adequately control when an AC coupled solar array turns on and off. And while that doesn't prevent the batteries from charging up to 100%, it prevents the batteries from operating at 100% when the solar production should be greater than the load. And that can be solved with customer education, and that's not a huge deal when you're not losing power frequently, but it is confusing. On top of that, there's the generator aspect, and you have to be very careful with how you connect generators and AC coupled solar. For example, the generator port, and this is true for the NV, it's also true for the Solarc. The generator port is not capable of black starting, in terms that if you crank up the generator and your batteries are dead and there's no solar present, you crank up your generator, then inverter will not start with that generator port. Now, if you have an automatic generator with an auto start, it's not a problem. That generator is going to start when the batteries are at 10% and always keep your batteries there. So this is a very much an edge case circumstance, but when you sell thousands of batteries, you will interact with people who encounter those edge cases. And you say, okay, well, the grid side of the inverter definitely has black start capability because when I haven't installed my battery yet, I can still just do solar only, and even if I haven't installed solar yet, I connect the grid and I can turn the inverter on and it turns on. So I know that the grid side can turn the inverter on by itself. And so I'm just going to go connect the generator to the grid side of the inverter. And that's fine. That's a valid configuration. If I were living off grid, I would connect the generator to the grid side just so that if I happen to deep discharge my batteries all the way, I have a backup option to turn my inverter on so that I could use my inverter to charge the batteries. Now, in the case of the NV, we really start to split hairs. The reason is the NV can run a small load with just solar power by itself. And so if you were to deep discharge your batteries to the point where you needed to turn the inverter on to charge it up, you could just with solar turn the inverter on, but only run less than a 1 kilowatt load, like only run enough to trickle charge your battery up and recover that way. So we're kind of talking about user experience issues to make things completely hands-off, which is definitely what the customer wants. And you say, okay, well, Now I'm going to go and tie my auto start generator to the grid side and turn it on. Well, the problem at that point is your AC coupled solar array doesn't know if this is the grid or if it's a generator, and it'll want to backfeed the generator. And so the real takeaway from today's program is that AC coupling is going to be the easiest path forward and the most pragmatic path forward. But when you combine AC coupling with generators, you either are putting them on a transfer switch so that they cannot run at the same time, or you have to heavily educate your end user to say, don't use that generator when the solar array is running. Program it so that it cannot come on, when the sun's up, for example. And I assume all those things are going to get easier on customers, as time goes on and software gets better developed. And so does this mean DC coupling is best because it has better control over the solar array? And when you're in backup mode of operation, you can run the battery and keep the battery at 100% while you do so? Well, technically, yeah, I think DC coupling is best. Under a new construction scenario, I would absolutely do DC coupling every day of the week. But that's not for retrofitting. And with DC coupling, you still need module level panel electronics for the time being. There is a new UL listing called 3741 that allows installers to get rid of the module level panel electronics. To no longer use optimizers or microinverters, but just to let the solar circuits be solar circuits up on the rooftop. But in order to list with UL 3741, it's a combined inverter and racking listing. And so to take advantage of not needing module level panel electronics on the roof, you will likely have to replace your racking system in addition to your inverter system. So it's not a great retrofit solution if you have a solar array that doesn't have MLPE and you're like, oh, I'm just going to use a UL 3741 system. You're still going to have to take your existing inverter off. You're going to have to take the modules off the roof and replace your racking. At that point, you might as well treat the project like a new construction project. And that's why you're doing DC coupling, but that's not your easy AC retrofit on and off the job site in 2 or 3 hours, doing $20,000 projects in a half a day type of goal that we're seeking with retrofitting. And there's really, unless you're experiencing inverter failure, unless you've seen a couple of microinverters fail and a couple of optimizers fail, and you've been around the block a few times and you know that, if I get up on that roof and I replace 3 optimizers, what's going to prevent 6 months from now the customer calling and being like, well, a few more failed, and now you're getting back up on that roof to replace a few more optimizers. There's nothing wrong with taking the existing system off and replacing it with something that's better, something that's new. Sure, keep the solar modules, whatever. But there's also nothing wrong with extracting the most amount of value out of the existing infrastructure you have on site. It kind of comes down to customer preference, customer budget priority, how reliable do they really need their system to be. And what I would say is, if you are AC coupling, just go with the most simple path. Do AC coupling because it's simple today. And then if the inverter fails down the road, the solar inverter, you still have the the solar side of the hybrid inverter that you haven't even used yet to do your, project refresh. Just don't get up on the roof to replace the existing roof mounted electronics until it is time to do so. Okay, what about 400 amp service? Well, there's two ways to go about designing for 400 amp service, and it's you get what you pay for on this approach, because one way is more expensive and more involved than the other, and it is really better than the other, but not the two options are not. You don't always have to go for option A and not option B. Option B is really simple. It's you have the grid come in, and more often than not, whether it's in the meter base or some kind of sub panel, but your 400 amp service comes in and then it splits off into two separate 200 amp panels. And so the retrofit option would be to put two 200 amp pass through hybrid inverters, one inverter on each panel. Very simple project to do it that way. But the problem is when the power goes out, you only have 12 kW of power, and that is not going to be cumulative. You do it this way, you only get 12 kW on panel A, and you only get 12 kW of power on panel B. And, for most 400 amp home services, 12 kW on either panel is not going to be enough. But if it were cumulative, where you could have not 12 kW per panel, but 24 kW total, well, for 400 amp service, that still might not be enough, but maybe 36 kW or 48 kW could be enough. And in order to do that kind of retrofit, basically you have to have the power come in from the grid, and then a 400 amp AC distribution panel. And that might just be a box with power distribution blocks inside of it. But the grid side of all your inverters tie into there. And then you have the same thing on the other side where the load side of all your hybrid inverters tie in to give you a true 400 amp output. And then you split off to your two 200 amp panels. So this is true for new construction as well as retrofitting. But if the question is, well, how do I back up a 400 amp home? There is kind of a cheap way to do it, but there is a better way, which is to combine the AC side of the grid and combine the AC side of the load together. And that way it doesn't matter which panel is the heavy hitter, the inverter capacities are tied together. Just as a final note, with the Fortress product line, our NV inverters do 200 amp pass through, but it's hard to transfer this much power and disconnect this much power during a power outage without having breaker damage. And so to be conservative on that, the way that we do cumulative pass-through is you get 200 amps for the first inverter and then 100 amps for every inverter that you stack in addition to that. So in order to do 400 amp service, you need at minimum 3 12 kilowatt hybrid inverters. And then again, many jurisdictions will still want to see some load control implemented on site to make sure that during that backup phase, you have that ability to remain powered. Okay, so the last topic is, well, what about Tesla style interconnections? And what I mean by that is, so far we've just talked about the grid coming in and you putting one big battery inverter between the grid and the load, and then maybe have some AC coupled, solar on the gen port, or some DC coupled solar on the hybrid inverter. That's the a style that has been popularized by Solarc, especially if they're Solarc 15K, and that's equivalent value of what the NV12K provides. The Tesla style is a little bit different. They separate out the transfer switch and the grid disconnect from the inverter and the battery system. And so what that means is, if you only need one inverter, if you only need 12 kilowatts of backup power, the hybrid all-in-one solution will be the cheapest and easiest option, because one big thing is generally cheaper than two small things. You get some economies of scale by keeping it simple. The problem is, when you are trying to build not just one or two inverter systems, or even three inverter systems, but what we've seen is with three inverter systems or two inverter systems, you have to have these additional combining panels to tie everything in together. But then you're also buying 200 amp pass through, 200 amp pass through, 200 amp pass through, 200 amp pass through to get 12 kilowatt, 24 kilowatt, 36 kilowatt, 48 kilowatt. And 48 kilowatts of power is only equal to 200 amps of real AC power. And so what I really mean by all of this is that the more hybrid all-in-one inverters you buy for larger and larger whole home backup electric services, the more bells and whistles you're buying. The Tesla inverter only has one input and output, whereas the Solarc or the Envy has a separate grid input and a separate load output. And so, one thing costs less than two things. And especially if you're talking about multiple inverter systems, you're buying a whole bunch of bells and whistles that, by removing the 200 amp pass-through capability from the inverter and removing the grid disconnect from the inverter, or that grid transfer from the inverter, you let the inverter just be an inverter, and so the costs go down. And so where it really, you pick up cost savings by having a hybrid all-in-one, but when you try to scale it up and say, okay, I need multiple inverters on site, the Tesla style format begins to be a little bit more cost effective. And so what's the solution for that? Well, the solution today is, with the Fortress product line, is you still use multiple NVs to get to 36 or 48 kW of backup, regardless of whether you're on 200 amp or 400 amp service. Maybe I messed up on the slides a little bit, but what I wanted to point out is that we do have a high voltage line that's coming out a little bit later this year with a smart load panel that will enable that Tesla style of system design and system format. And the reason why we're doing this with high voltage is because the battery inverters themselves are even more simple than these 12 kilowatt all-in-ones. And so, in the future, when customers start wanting 30 kilowatt, 30 kilowatt hours, 40 kilowatt, 40 kilowatt hours, Fortress will have a product line for that. But for the time being, just using so when I want to get into 30 kilowatt, 10K per inverter, 30 kilowatt hour, battery stack, tying it into an external transfer switch makes a lot of sense. But today, for the simple project, we use the Fortress Envy, and we do have an outdoor rated battery cabinet for the batteries. And even though the inverter itself is outdoor rated, we do have a NEMA 3R cabinet that can hold both the inverter and the batteries together. And the reason, while you don't need it, and to some extent, putting an inverter inside a cabinet when it's not needed to go inside a cabinet will add some cost and complexity to the project. The reason why you do it, and this will fit the Solarc 15K as well as the NV12K, but the reason why you do it is because it just gives a nice, clean aesthetic, a nice, secure aesthetic where you don't have all these wires coming out the back of the system that aren't protected. Families with kids, they don't want their batteries and the inverters just hanging out in the garage because they don't want kids to, poke at them. Having a nice, robust cabinet that the thing can go in has its advantages. Okay, so that pretty much covers what we're talking about today. I'm going to put the certificate request form in the chat again, and then I'm going to get into Q&A. So if you don't see the certificate request, you should have it. Is the meeting being recorded? It is being recorded. We have a training portal at Fortress. If you just go to Fortress's website and go into training, you'll get into the training portal. This is not part of our certified dealer training, which is more product focused. This is part of our NABCEP training. If you need a 12-hour or 30-hour NABCEP class for recertification, you can enroll. And if you're already a Fortress dealer, you can enroll at a discount. If you just want access to the course recordings and you're fine with taking our live webinars and getting the free certificate as you go, just go to the training portal and enroll into the free course access, and that'll get you access to all the program recordings and transcripts. So we're not trying to silo this information off. We want your whole team to be able to access it regardless of whether or not they're in NABCEP. So hybrid inverters are transformer based. No, our NV inverter is a transformerless inverter. And so you say, well, how reliable is a 5 kilowatt NV for use with a 1.5 horsepower inverter air conditioner? The NV that we're selling in the United States, the one you're going to want to use for the most part is our 12K model. It's 12K transformerless, and that is somewhat equivalent to the Solarc 15K in terms of performance. Can handle about a 3.5 ton air conditioner. But if you really want to run, a 4-ton AC or anything larger, or simultaneously running that air conditioner all the time with other loads, you'll probably want to get 2 inverters, not just one. Does Fortress use lithium ion or safer chemistry? Yeah, we use lithium iron phosphate. And the difference between lithium iron phosphate and lithium cobalt is that lithium cobalt will induce thermal runaway around 475 degrees Fahrenheit, and lithium iron phosphate will induce thermal runaway around 520 degrees Fahrenheit, which doesn't sound like that big of a difference, but it's enough of a difference so that when thermal runaway occurs in a lithium cobalt cell, it spreads from cell to cell to cell. But per our UL 9540A large-scale fire testing, we've demonstrated that does not occur with Fortress batteries. The way I think about it is if you put a Fortress battery inside of an oven and turn the broiler on at 500 degrees, it would not catch the battery on fire. But if you did that with a lithium cobalt battery, it would induce thermal runaway. So what device is the generator port in? The generator port is in the NV inverter. So this is the NV wiring block, and what you can see is that we have a battery port, generator port, load port, grid port. So this is the lower wiring compartment of the generator port. What happens when the batteries are full and the grid goes down? Does the NV or the solar curtail the grid tied inverters? Yeah, so when the batteries are full and the grid goes down, the inverters will frequency shift and turn the AC coupled inverters off. And they will not allow the AC coupled inverters to come back on until the batteries have dropped down to about 80%. So that's the main drawback of AC coupled systems, is that it can confuse the customers when they have a power outage that the sun is up and their solar array should be producing, but their batteries are at like 90% or 85%. They're like, well, why? I'm going to run out of power. The power's out. I need my batteries to be full, not 85% or 90%. I need them to be 100%. And the reality is they just have to wait for the batteries to drain down to 80%. And then the inverters will turn back on and charge the batteries up. If that's not acceptable to them, then they would have to go with DC coupling, which is more of a controlled charge. And in that circumstance, they might have to take the panels up and swap out their MLPE and put the panels back on. So let's see. We are seeing, just for your information, we're seeing pricing for single 400 amp 80 space panels approaching the cost of two 200 amp 40 space panels, especially when looking at main lug only. So that's great feedback, Matthew. 400 amp stuff in the past has cost an arm and a leg, and it's been easier just to go buy two 200 amp panels instead of one 400 amp panel. But if people so then it's like, well, if you have two inverters that have 200 amp pass through, you get into that more simple configuration. But what you really want to do is tie in your inverters together. Now with a 400 amp panel, all I would recommend is just getting some junction boxes and power distribution blocks and going with at least 3 NV inverters, if not more, to back up your 400 amp panel. And so what Matthew is saying is that we might see 400 amp electric service in the future actually be 400 amp electric service rather than be subdivided into two 200 amp panels. Okay, what is the phase imbalance in the NV in backup mode? Well, I think that we will start to see YouTubers putting through the inverter through some rather robust stress testing, and I think they'll be pleasantly surprised. We run our NV inverters with up to an 8 kilowatt phase imbalance, and so it has very robust phase imbalance without the use of a auto transformer or anything like that. So I think installers and customers will be very happy with our phase imbalance management specifically. So Andy said, I missed this. Is the NV rated for a 200 amp pass through? Yes, it is. It's a 12 kilowatt inverter with a 200 amp pass through. And so for some customers, they're just going to want you to put the inverter on. When the grid's up, they have access to 200 amps. When the grid's down, they only have 12 kW. Some inspectors will say, well, per code, if you're backing up that load, you need to be able to demonstrate that you can fully power it. At that note, well, if you're not AC coupling, you still have use of the generator port for some load control. So you could put a load shedding panel onto that. Or, what we're, kind of where we're moving our product line to going on towards the end of this year is that we have um, a microgrid disconnect panel. That's the Tesla style panel. So that's in the, let me try and pull up this graphic again. So in the Tesla style, and I hope I'm still sharing my screen. I think so. In the Tesla style uh, panel here, we have a transfer switch that disconnects from the utility when the power goes out. And the thing that's funny about Tesla is I modified their graphic. Their real graphic shows a backup loads panel and not their whole house. But customers really want whole house backup. They don't want to back up just critical loads and not others. And one Tesla at 5 kW is laughably small. There's no way that it can back up a home. 12 kW is barely passable, but definitely you can go over 12 kW with your home if you have, say, an electric water heater versus gas. If you have a gas home, 12 kW may be all you need. But where we're going with the Allure gateway, if you will, we were calling it the Allure microgrid panel, is that it has the microgrid disconnect that also provides the 200 amp pass through, and it has an energy distribution panel on it where you can tie in multiple inverters together, but it also has a load control module built into it. So it does load control and energy distribution and your microgrid disconnect. So when that comes out later on in the year, that will be a solid answer to inspectors who want to see some load control on homes that don't do a true 200 amp or true 400 amp backup, but do something less than that. I also think that in the future with high voltage, that it'll drive down the cost of inverters to the point where people will start doing 30 kilowatt or 40 kilowatt of backup, and load control will be less important. But in today, for going into 2023, what we have is a solid 48 volt hybrid inverter solution. What PV voltage does the charge controller start to charge the battery? So the PV voltage turns on around 100 volts, and then it goes up to 600 volts. So that's a big difference between our 12 kilowatt hybrid inverter and some of our competitors' 12 kilowatt hybrid inverters. They may only go up to 450 or 500 volts in their design voltage. Our design voltage goes up to 600 volt. And in some cases with retrofitting, like if you do have a Fronius inverter or an SMA string inverter and it's approaching 12 years old and you want to just take it off the wall and put in a battery inverter instead, unless you're going to be subject to updating your system to rapid shutdown, the project could be as easy as taking the old 600 volt batteryless inverter off the wall and putting the new 600 volt battery inverter, hybrid inverter, on the wall. Okay, Don and Rowan, you have some raised hands. Matthew, I think we've been talking to you. But if we have any more questions, just go ahead and start typing away, because we're getting down to the end of the list here. So let's before we end, go take a look at the Fortress website. So if you go into products and go into residential, you'll see our NV inverter. So you can go here, get more information on it. It's just now starting to go into distribution. So most distributors aren't going to have it until the end of the month. And then if you go into our training portal, that's where you can go and get access to, training resources. So go into Fortress, go into the training portal, sign up for our dealer program. If you're an installer, distributor, we want you to be in the dealer program, and that's going to become increasingly important that you do so. We also have the NABCEP program, which is free to audit. So if you want to train up your staff, what we do when we hire new engineers and also new salespeople is we sit them down and say, well, go through our NABCEP program and, start getting familiar with industry terms and conditions and design techniques. And, any member of the general public can do that as well. You have to pay for the certificate of completions unless you take our live webinars, but all of the content itself is free to access. So what types of monitoring portals do we have for the systems? So what we have, this is launching this month as well. So Fortress has never required monitoring for our warranties. Maybe I deleted the slide for this program. Probably so. Let's see if it's on our website then. So we've completed the field testing of our Guardian Monitoring Hub. So this will be available for purchase next week, actually, end of next week. So right now it is just a simple monitoring hub for telling you, your battery state of charge, individual batteries. So we've been piggybacking off of our inverter partners' monitoring systems to date. And the Guardian currently is just for monitoring the batteries. And we have a separate monitoring app for monitoring the NV inverter. So there are monitoring apps available now for iPhone and for Droid for monitoring both our batteries and the inverters. You will need to buy a Guardian monitoring hub to monitor the batteries. And as time goes on, one nice thing about software is you can make changes to it. As time goes on, you'll see the monitoring platform become more integrated. But you get a monitoring platform for the inverter where you can get inverter analytics. You can adjust inverter settings. You can also connect to the inverter locally to do some local monitoring over Wi-Fi. Will the NV be able to be configured remotely like the Solar? So yes, it will be, or rather it is. And what I would say is while the NV has been going through field testing for quite some time now, to where you can be confident installing it and using it. And in some ways it's a more refreshed new design as a color touch screen. If you're already installing Fortress Solar combinations, that works. Keep doing it. We're not trying to talk people out of Solarc. They have they have good support, a very popular platform as well. But if you are looking for other inverter options, and particularly if you want to do like 18 kilowatt or 20 kilowatt solar arrays on one single inverter and really optimize your project costs that way, like getting down to, when you look at our retail price for the NV, and you put 20 kilowatts of solar on it, per DC watt, that pushes the cost of the hybrid inverter down to about 38 cents per watt, which is pretty incredible. So if you're a dollar per watt junkie and you really want to optimize your dollar per watt costs on your project, I think you're going to really like the NV. Someone mentioned phase imbalance. I think that's another really good reason to check it out. But down the line, when the inverter monitoring and the battery monitoring become one and the same, it'll be a little bit more of a platform experience. So yeah, we're very excited about it. It'll make our technical support lives a lot easier. One of our sales guys has a great saying, customers, they really want one throat to choke when it comes to technical support. And also, UL, they with these inverter battery listings, it's not that we wanted to develop our own inverter. It was really that we had to. UL has gone a little crazy with their system level certification approach. And while they say, oh, well, you don't need to go get every combination of every battery and every inverter UL listed, the test labs say you do. And so the UL says, oh, well, you can just write a compatibility sheet between all your different inverter and all your different battery configurations. Well, the test labs don't sign off on compatibility statements. They sign off on testable configurations. And so the migration from UL 9540 edition 1 to UL 9540 edition 2 got rid of the concept of a DC energy storage system, which to Fortress, it didn't make any sense because all of our batteries contain all the safety features needed to pass the UL 9540 safety standards. Like there's literally no change between our batteries for passing their safety standards for UL 9540 edition 1 to UL 9540 edition 2. The only difference is there's an inverter hanging out on the wall during the UL 9540 edition 2 certification process. So that gets too costly, and so that's why the primary reason why we pulled everything into one system. But we still will continue to develop our communication with Solarc and support Solarc inverters. And certainly when you get into large system configuration, when you're talking about doing 6 inverters or 9 inverters with, say, eVault Maxes. So a very popular design configuration is 9 Solarcs or 12 Solarcs and 20 eVault Maxes to kind of form, what's really getting into small commercial battery systems. I would stick with what's tried and true and keep with the Solarc in that configuration. All right. Well, I apologize for a little bit of the harsh lighting. We've moved into our new office and are still getting our desks and items placed on the walls. So next time we'll probably have a little bit of a less utilitarian setup. But all right, we got another question. Are batteries needed for the NV to operate as grid tie? I have a customer who wants to install the grid tie now, but add batteries later. So that's a great question. The NV inverter does not need batteries to operate. So you can absolutely do the NV now with solar only. We will also allow you to do the NV with lead acid. So if you wanted to do a very low cost backup only type of configuration, you could do solar with the NV, or you could do lead acid in solar with the NV, and then just continue to wait for lithium to come down. We will not warranty or support the NV for any other lithium battery other than Fortress battery product. All right. Well, happy Friday, everyone. We're going to work on this recording and then upload it into our training portal. So if you have people who you think would benefit from taking it, send them on over to the Fortress website. Tell them to sign up for our training portal, and we'll get your staff trained. All right. Thank you. And you all have a great weekend.